Hello and welcome. My name is Seiko, and in today's presentation, we will explore the evaluating volatilization gravimetry. This method plays a critical role in accurately quantifying volatile substance in various samples, making it essential in a wide range of fields including environmental science, chemistry, and material analysis. So let's dive in and start evaluating how this technique is used to measure the mass loss of volatile substance in laboratory experiments. By the end, you will have a clear understanding of its significance and potential in scientific research. And now, let's get started. Okay, so our topic is all about evaluating volatilization gravimetry. Volatilization gravimetry is a technique used to determine the amount of volatile substance in sample by measuring the mass loss after heating. The volatile substance could be water or any solvents or other volatile components like organic compounds. It works on the principle that when a substance is heated, the volatile component evaporates, and the mass loss is directly proportional to the amount of volatile substance. Principle of volatilization gravimetry. When a sample is heated to a specific temperature, the volatile component will vaporize or volatilize and escapes. And remember, the non-volatile component remains as a solid residue by measuring the mass of the sample before and after heating. You can calculate the mass of volatile component by the difference. We have here 4 steps in volatilization gravimetry. First is weigh the sample, second heat the sample, and third is weigh the residue, and fourth is calculate the loss. And let's begin. Yes, first we need to weigh the sample. Accurately weigh the sample before heating. Second is heat the sample. Heat the sample in an oven or furnace under controlled condition, typically to a temperature where the volatile substance will vaporize, but the non-volatile substance will remain the same. And the third step is the weigh the residue. After cooling, weigh the remaining residue to determine the mass of the non-volatile component. Last steps is calculate the loss. The difference in mass before and after heating corresponds to the mass of volatile substance. Let's proceed to the example. But first, allow me to read this example. This example is determining the water content in a sample. Weigh the 5.00 grams of hydrated salt, and after heat, allow the sample to cool and weigh the dry residue. Suppose the mass after heating is 3.400 grams. Now let's proceed to the calculation. So we need to find the initial mass. The initial mass of hydrated salt is 5.00 grams. And the final mass after heating is 3.400 grams. And the mass of water that lost is 5.00 grams. Subtract to 3.400 grams. The answer of this one is 1.600 grams. Therefore, the water content in the sample is 1.600 grams. From the calculation, you can determine the amount of water loss or the volatile. This technique helps in determining the purity of the sample, as impurity not volatiles will remain as residue. And take note that the higher the mass loss, the greater the proportion of volatile substance in the sample.